Alright guys, now let's have a look at question 3. Question 3, it was an analytical geometry question. If you have not watched question 2, please go back or check at the end of this video. There will be a playlist where you can see question 2 as well. Otherwise, please stay tuned, watch until the end where you will be able to get question 4. In this diagram, they said in the diagram below are triangle RPQ. Let's see, here it is. We see the triangle with coordinates given the S0 is to 6, Q is 4 is to -2, M is -2 is to 0, where M is the midpoint. All right, of this line here RQ. So this is the midpoint. Okay, as we can see, they already marked there for us. This question is I feel like this question they were just giving us marks here, guys. So questions like this, guys, please make sure that you do scoop total on this question, especially analytical geometry, one of my favorite chapters in maths paper 2. All right, so let's go ahead. They said find the gradient of MQ. All right, I'm gonna put 3.1 here. Gradient of MQ, gradient of MQ is going to be given by y. Where is M? M is here and Q is there. So I can say here that is going to be given by the, let's see, you can say here the excuse me, you can say here the y at M minus the y at Q is equal all over the x at M minus the x at Q. I know what you're thinking, guys. Maybe some of you will be thinking, what if now you just did y2 minus y1 all over x2 minus x1? Doesn't matter, just have to know that this will be your coordinate number 1, this will be your coordinate number 2, or the other way around, this will be 2, this will be 1. As long as you follow the sequence of how you minus each coordinate from the 1, then you should be fine, guys. All right, so therefore M is going to be minus 2 minus 0 all over the, excuse me, all right, it's negative, yeah, -2 do minus that, and then therefore, wait a minute, okay, no, sorry guys, I'm substituting wrong here. Okay, the y at M is 0 minus the y at Q is -2. There you go. And then there we go. And then the x at M is -2 minus the y at Q, which is equals to 4. Okay, great stuff. Let me double check here. This is the y at M is 0 minus that, and then the x at M is -2 minus 4. All right, so therefore if we punch this into our calculator, we found out that our M is going to be here, is going to be equals to 2 over -6, which gives us 1 all over -3. So it's -1 over 3 in this case. Let me just put the negative there, -1 over 3. All right, therefore 3.2 will say determine the equation of the line MP, which is this line here, in the form of y is equals to mx plus c. All right, so therefore it means we need to find the gradient of MP. But if you have a look at the gradient of MQ is perpendicular. MQ, you can put it here, say the gradient of MQ is perpendicular to the gradient of MP. So therefore if we have got, remember the product of these two gradient must give us -1. So therefore we are looking for the gradient of MP, which is will give us -1. So therefore if you can here, you can just divide by or multiply throughout by -1 over 3, by -3 over 1 rather, by the reciprocal of that, which is -3 over 1, which in this side everything would cancel out, and therefore this side multiplied by negative 3 over 1, which is equals to the gradient of MP will give us what? 3. Right, so therefore we can use this equation here, y minus, we choose any value between m and q. We can choose any value, really doesn't matter. I'm going to choose this value here at p. Sorry about that, guys. I'll choose this value here at p. So it's going to be y at p minus the gradient of mp, all in brackets, x minus x at p. Great stuff. So y minus y at p is equals to 6, is equals to gradient at p is 3, therefore x minus x at p is 0. So therefore you're going to have this equation here. If you take 3x, then you take this y to that side, is going to be positive 6. There you go. How will you check that if this is correct? You can substitute this value here of m to check if this is correct. Right. And now let's move on to 3.3. It says here 3.3, we need to determine the coordinates of r. Coordinates of r, where is r? R is sitting right here. They said if this is the midpoint, you have got 1 point. You can use the midpoint formula to find the other coordinate. So 3.3 will have to be, you've got a line there. There is our line with m and q there. We've got the midpoint already. We are looking for this r value here. So this is what I call midpoint in reverse, guys. So you need to know how to use the midpoint straightforward or midpoint in reverse. So if we were to use the midpoint, you say x at the midpoint is equals to x at r plus x at q all over 2. Similar thing would apply with the y. Y at midpoint should be equals to y at r plus y at, oh, look at me now, what am I writing here? Plus y at q all over 2. Okay, so let's start with the x value. What is the this is minus 2 is to 0, and then here what do we have? We've got 4 is to negative 2. Right, so therefore here what do we have? We've got negative 2 is equals to the x at r, which is the one that we're looking for, and then the x at q, which is going to be plus 4 in this case, all over 2. Therefore you can cross multiply here. If you were to cross multiply 2 times negative 2 is going to give us negative 4 is equal to x at r plus 4. Okay, so now you take 4 to this side, is going to give us, therefore r is going to give us negative 4, which allows us to say x, xr is equals to negative 8. Okay, that's coordinate number 1. So therefore if you continue here, you're going to say y at midpoint is 0 is equals to y at r plus or minus, okay, y at q is a negative 2, so you're going to say negative 2 here, all divided by 2. You cross multiply, 2 times 0 is going to give us 0. It's equals to y at r minus 2. Therefore it means y at r is going to give us negative, no, you take 2 to the other side, is going to give us positive 2. Right, so therefore you tell the examiner that the coordinates of r will be negative 8 is to 2. Great stuff. Let's move on to 3.4, 3.5 and 3.6. Okay, here we go. Here 3.4, it says calculate the length of PQ in simplified sets form. All right, here we go. 3.4. Okay, what they want us to find, calculate the length of PQ. You're going to have square root. You can use the formula here, guys. You can say x we need to use the formula here, guys. You can say x at I'm just going to my formula sheet here, guys. Sometimes everybody else do forget these formulas, but it is wise to check and double check yourselves to avoid any mistakes. All right, pq therefore squared plus yp minus y at q, then squared. You do have the coordinates of both p and q, so is this length here. All right, so therefore here we go. We're gonna have x at p is 0 minus x at q, which is equals to 4. Then everything needs to be squared here, plus y at p, it's x is 6 minus into minus 2. Don't forget the minus, guys. Always put it in brackets. Therefore, if we put that, then we can go straight into our calculator, punch that in. Let me see, what am I going to get as I go along. I'm getting, let me know what you're getting, guys. I'm getting 4 square root of 5. 4 square root of 5. 4 square root of 5. Here we go, 4 square root 5. That's what I got. Right, so therefore, and then they said, yeah, let's move on to 3.5 rather. 3.5. It says here, given that RP, okay, so it's RP Q and then T, okay, let's just say T somewhere there, is a parallelogram. So it means this thing would be like this. If that's there, it's a parallelogram. I said to us, determine the coordinates of T if T point is in the third quadrant. Oh, okay, there it is there in the third quadrant. So it means x is negative and also y is negative in this case. So now if they say that, it means, okay, let me try to put it nicely here so that I don't cause confusion. All right, so it means this T will be somewhere here, sitting somewhere there, because this line will have to be straight to this point here, and then also this one will have to be to this point there, and then we have got this Q here. There you go. Right, so now if you have a look at this one, guys, this midpoint is also the midpoint on the line PT. Line PT, it has M as its midpoint. So what you can do, you can also find the coordinates here in this case using similar method as in 3.2. So let's go ahead. We're going to say, okay, x at midpoint. So what you have here, you've got this line here, and then you've got a midpoint there. What do you have? You've got point P, which is called 0, 6, ne? All right, and then you've got point T where you don't have the coordinates, you're looking for them, and then here at midpoint you've got minus 2 is to 0. Great. So therefore what you need to do now here is to find the other coordinate at T. Coordinate at M is equals to x coordinate at T plus x coordinate at point P all over 2. Then similarly you would do the same here. Y at midpoint it's equals to y at point T plus the y at point P all over 2. All right, a midpoint, the x at the midpoint equals to -2. It's equals to x at point T, and then therefore the x at point P is 0. So therefore the here would be 0 all over 2. Therefore, if we're to continue here, my battery is low. Okay, so if we were to continue here, you would say 2 -2 is going to give us -4. It's equals to x at T. Right, so therefore similar thing you would do here for y at midpoint is equals to 0. It's equal to y at T plus y at P all over 2. No, sorry, y at P is equal to 6 rather. Y is equals to 6. Therefore when you cross multiply here, you're going to get y is equal to -6, because 2 times 0 is equals to 0. So therefore our y value in this case would have to be that. Okay, which kind of makes sense, guys, because now both of the x and y here, they are both negative. You can come here and tell the examiner that therefore t will have to be -4 is to -6. Great. All right, and then now let's move on to 3.6, which is the last question on this one. And then 3.6, it says here, explain why R P Q T is a rhombus. All right, it is a rhombus because there at the midpoint, guys, there at the midpoint you have got what? 90 degrees. You have got a 90 degrees. All right, so what you can say here, you can say the diagonals of the parallelogram, they are perpendicular to each other. Okay, that should be your answer. You can say yes, the diagonals of the, no, that's not the case. Okay, 3.6, you can say that okay, you can say that, remember, in the parallelogram, if you must know the properties, guys, here this is 90, this is 90. So in the parallelogram, these diagonals, they are not necessarily 90 degrees to each other. Some of them they are not. So you can say here this is a rhombus. Explain this should be a rhombus because diagonals they bisect each other at 90 degrees. Each other at 90 degrees. There you go. Right, they bisect each other at 90 degrees, and that's how you deal with a question like this one. I was trying to be as slow as I can to make sure that you guys fully understand this concept of analytical geometry. If you do more examples, you will get it right. So please make sure that you stay tuned, and I will see you on the next upload where we'll be doing question 4.